Hey everybody, my name is Tom Tullis. This is the Tomb of 3D Printed Horrors, and today we're going to take a look at my latest Cura profile for printing 3D miniatures on an FDM printer. Um, about a year ago, maybe 10 months, I forget what it was exactly, I did a video on how to print 3D printed miniatures. And I went through all of the ins and outs of it. I'm not going to cover all of that again. I'm not going to rehash it. I'm going to go ahead and link that video at the top of the screen now. Go watch that first before this video. Most of that information is still valid. The only thing that I am updating in this video is the actual Cura settings. And the reason for that is the Cura profile I used in that video was kind of a Frankenstein profile. It was an update of my original Cura profile that I had used on my Ultimaker 3D printer. And the reason for that was the Ultimaker uses Cura natively. It is a Bowden feed extruder, which means it's very much like an Ender or an CR10. And so that was a good place to start. But I always wanted to go back and start from scratch and create a profile, a dedicated profile for the Ender 3 and subsequently the Ender 5 and CR10. And that's what I've done here. I went back, scrapped everything, and just started from scratch, and probably spent about 4 or 5 months creating this, and we're up to the third version of it with this video. So let's get started and take a look at what I've done here. I'm going to go through and give you just a brief overview of not only the settings I'm using, but I'm going to tell you why I'm using them, what these settings do. And that will hopefully give you a better understanding how Cura works and give you the ability to modify my profiles for whatever printer you're using, or for a model that's giving you some problems where maybe my stock profile isn't the best option. If you understand how this works, you're going to be better able to tailor it to whatever your individual needs are. So let's get started here. Layer height is pretty self-explanatory. I have that at 0.1. If you're screaming that that's not a magic number, you're damn right it's not a magic number. I don't use magic numbers. Magic numbers really don't come into play unless your calibrated Z height, your starting point, is already at a magic number. If you're not starting on a magic number, the number you set here is not going to be at a magic number. And I hate that term. I have a whole video on it. I'm going to link it above if you want to watch on how I arrive at optimal layer heights. Briefly put, 0.1 will give you the most consistently good results for a 28 millimeter miniature using a 0.4 millimeter nozzle across the board. And my video that I linked above will go into a lot more detail on that. If you want to use a full step increment or a so-called magic number, you could bump this down to 0.08 or 0.12. What that does do for you is even if you are starting at a non-full step increment, you'll consistently be hitting the same non-full step increments with each revolution of the motor, and whatever errors you are encountering there will be the same errors throughout the Z height of the print and presumably look more accurate. But you still don't need that. With 0.1, 0.1 is a precise half step, and my video explains what that means, but precise half steps are extremely accurate. So either way, if your Z height is not starting at a full step increment, 0.1 is going to look great. If it is starting at a full step increment, 0.1 is going to look great because it's an exact half step. So again, this is going to be your best starting point. You can experiment with this and see what works best for you on your machine. But for most people, they're going to find 0.1 is the optimal place to begin. Initial layer height, I bump my 0.1 up to double for 0.2. This just gives you more plastic being extruded on that first layer. It's going to come out more cleanly and be able to better accommodate any fluctuations in the surface height and give you a better adhering first layer. Line width, these are all set to 0.4, which is our nozzle width. I know some printer profiles out there bump these up a bit, like 0.42, 0.43. I am currently experimenting with this. I'm not seeing any real difference in results. So I'm likely going to keep these at 0.4 for the foreseeable future. But if you're watching this video 6 months from now, a year from now, and the current Fat Dragon Games printer profile has these bumped up, that's why. I've done more testing and have come to the conclusion that it gives better results. But as of now, I don't see changing them. Top bottom line width, I set this to 0.3 for miniatures. The reason is that's going to cut the amount of plastic extruded, and when you get to the tops of miniatures and stuff, you're dealing with very tiny areas anyways. This also forces the nozzle in closer to itself on each pass, and it just gives a cleaner looking top surface to your miniatures. Infill line width, skirt brim line width, I just leave these at 0.4. Initial layer line width is 100%. Some people dial this up a bit to give extra squish on the first layer. I don't. If your bed is properly calibrated for Z height, you don't need to do that. You're going to get a good first layer. Wall thickness, my original video goes into a lot of depth on this. I'm not going to repeat that here. Just know that 3 walls will give you all the strength you need for a 28mm miniature. You're going to have a wall on opposite sides of any layer, which means you're going to have 2.4 millimeters of plastic in the shell alone before you have any infill. That's almost 1/10 of an inch of plastic. For a 28mm miniature, that's plenty strong. Outer wall wipe distance, what this is doing is just wiping the nozzle off a little bit, letting it take care of any ooze on the outer wall pass when it's printing that, and it just makes a cleaner surface. You don't get little zits and stuff as much then. Top surface skin layers, what is this? Why is this different than just top layers down here? Well, the difference is, yes, it's printing them identically, whatever patterns you've selected down below and such. Top bottom pattern, I've got set the lines. The reason Cura splits these two things out is, if we scroll down here, it lets you set different speeds for them. So I can set my top bottom speed here on the miniature to 21 millimeters per second. But then my top surface skin speed, the very, very topmost layer, or layers, in my case I've set it to 2, I'm cutting that speed down to 15 to make it even more even. By slowing the nozzle down a little bit too, it helps those layers fuse a little bit more and the top surface look cleaner. And that's all that is. It's not that it's a different type of layer, it's just simply allowing you to set different speeds for the layers, and that's critical. This is one of the reasons you should never ever use, I know some people call it a trick, where they set like 999 top layers for a miniature, but all you're doing is disabling a ton of really great settings in Cura that let you fine tune your profile even further. You're just having Cura disregard those, and you're creating a lot of issues for yourself. So don't do something like that. Take advantage of all of the fine tuning that Cura offers. I mean, this is one of my big beefs with Prusa Slicer. It simply does not offer all of the settings that Cura does for fine-tuning these profiles. I've got a wonderful profile I've designed for Prusa Slicer I'll be releasing soon for terrain, but I still cannot get one that I like for miniatures simply because it does not give me all of the options that Cura does, and it really takes a lot of these working in conjunction with each other to create a really good, reliable miniature profile. So let's keep going here. So top surface skin layers, which are slower layers, I have set to 2. A lot of people do 1, and 1 will look good. 2 just looks better. Top surface thickness, I do 8 layers, which is 0.8 millimeter. Sometimes I like bumping that up to 10 for an even millimeter. It depends on the miniature, but 8 is absolute minimum. Same way for the bottom. Top bottom pattern, I use lines. Concentric or zigzag will look horrible on a miniature. Stick with lines. Let's scroll down here. Okay, this is really important. Optimize wall printing order and outer before inner walls need to be turned off. Never have these on for miniatures. Basically, when you print the infill and then the inner shells working outward, each thing you print is acting as a scaffolding or a lattice for the next thing you print. So the very last thing you print, you want to be your outermost shell. It has more things to grip to. It's not going to droop on overhangs as much, and it's going to look much cleaner. If you print outer before inner walls, your outer wall is only going to have the surface below it to adhere to, and it's not going to look as good. So always make sure you have this clicked off. This is the most critical one. Alternate extra wall doesn't really come into play on tiny stuff like miniatures. All that does is every other layer, it prints an extra inner wall for better bonding with the infill, but it just is going to create more time, have your miniature take longer. Just turn it off. You're not going to miss out on anything. Compensate wall overlaps. I'm really mixed on this. I still turn it off. I do see some benefits to it, but it also has some negatives. I see issues with some miniatures printed. What it's doing is where you have a wall, the multiple walls together, in this case 3, and the compensate wall overlaps goes into an area where those might be too thick. It would thin the extrusion, almost like what it does with coasting, in those areas, and let those walls print thinner. The problem is it's still not generating a tool path, for the nozzle that I like in some cases. I'm just getting more consistent results, and everything in this profile is about averages. This profile is not 100% perfect for every miniature available on the market. It has got the most average numbers to get the widest range of miniatures printed reliably. And that's the case here. Compensate wall overlaps will actually benefit you in some cases. It's just from my experience, it will benefit you more having it off for the majority of miniatures. So these two connect with that. You don't need to worry about those. Fill gaps between walls, have that set to everywhere. That's just going to make sure if you have any skips or anything due to the slicing path, it's going to go in and put an extra small wall extrusion in there to fill it in. Filter tiny gaps does the same thing. It's just going to even out your surface. Print thin walls, you want that turned on. That's critical for a miniature. If you have a super small detail, it will compensate for that and reduce extrusion. I don't do anything with horizontal expansion or initial layer horizontal expansion. I just leave those to 0. Z-seam alignment. Always have this set the sharpest corner. If you do it shortest or random, you're going to get little zits and blobs where the nozzle changes layer heights throughout the model. By setting it the sharpest corner, it's going to pick something like the edge of the shield or the edge of the cape to change the layer height, and that way those changes become virtually invisible because they're at a hard edge. They're not along a smooth surface where you're going to see the disruption more easily. Hide seam, extra skin wall count. What this is doing is where the skin, the side walls meet top surface layers, it's going to put an extra wall or two in to help overlap with those top surface and bottom surface layers for better bonding. You don't have to use this. I've just had it set at 2 for a very long time. I've never really changed it. I don't think you're really going to see a difference if you do bump that down, though. Infill density, 35% is optimal for these miniatures unless you're going to something larger. Like if you're printing a large dragon or something, you can bump this down to 10 or 15%. Infill pattern, go with grid. Do not, whatever you've read about gyroid and how strong it is and everything, gyroid is not going to come in, the strength of it is not really going to come into play on a miniature. Your strength comes from shell number. I go through this in a lot of detail in my original miniatures printing video, so if you want an explanation of why I'm doing what I'm doing, go watch that. But just choose grid. Gyroid, shortly put, is going to generate so many direction inertial changes for the print head. You're going to get a lot of vibrating on the printer, and that's going to result in ringing on the z-axis, so don't use it. All this is just stock. I don't really do much with it. Some people like upping infill overlap percentage to almost 20%. For a miniature, that's something for a larger, where you have some structural issues like terrain and stuff. For a miniature, that's not going to make a difference. Just leave it 10. Skin overlap 0.2, that could actually come up a little bit. Actually, that I'm gonna have to play with that some. I've had that setting forever and I've never really addressed it. I think on my next batch of testing, I will try upping that to maybe 0.1 and see how that works. But infill wipe distance, infill layer thickness, yeah, those are just stock. Infill before walls, you always want that. We talked about that earlier. Not doing supports, nothing Fat Dragon produces requires supports. Skin removal width, this is kind of interesting. You may read online or hear in videos where people put this at a much higher number, especially on large items. What this is saying is if you have a surface detail smaller than whatever number you set here, the slicer will ignore it and not slice it. This speeds up printing a bit. The problem is I've done a lot of testing with this. It really doesn't come into play much on miniatures. It comes into play more on terrain with like rougher, rockier surfaces. Anything over 0.8 on terrain tends to eliminate a lot of the finer details that we put in on stuff. So 0.8 is stock. The reason they're doing 0.8 is this is double your nozzle width. This could even get put down to maybe 0.6 or 0.4. I'll have to do some testing with that to go lower. If you do drop the number, it's going to increase print time a bit. So just be aware of that. But 0.8 seems to work really well, especially with miniatures. Skin expand I can't talk today, I'm sorry. Skin expand distance. Skin expand distance simply it's how far you expand the shells into the infill for better bonding. This is just the number again, I haven't done a lot of experimentation with this because you don't see it really. 1.5 works well for me. And again, 6 months, a year from now, I may have a different number here. But for right now, that's what I'm using. What else? Temperature. This is not set in stone. This is probably something I get at least 4 or 5 emails or messages a week on, people saying the number I've set in my profiles isn't working for them. It's not meant to. This is just a starting point. I generally print my miniatures depending which printer I'm using, what nozzle size, and what filament brand, down to about 200. 205 works well for eSun PLA Pro only. If you're using Hatchbox or 3D Solutech, you're going to need to drop this down 200 or even 195. But again, this is a starting point. Default temperature build plate for PLA 60 is optimal. Flow rate, this is only for Enders and CR10s. 92 of the people I've polled and had to do testing for me, 92% seems to be the average for a miniature. Now, for terrain, you're going to want to bump this up. But for a miniature, to get clean prints, 92% will do pretty good for you. If you are experiencing under extrusion with this, don't be afraid to bump it up. Go to 94 or 95%. I've had people even bump this down as low as 90. This is the lowest I can go and still get suitable extrusion. But again, this is a number that is likely going to change for you. You just kind of have to take a look at your miniatures. If you're getting more stringing and blobbing, this may drop to 91 or 90. If you're getting under extrusion with skipped layers, or your miniature is really brittle and breaks apart when you handle it, bump it up to 93, 94, 95 and see if that works for you. Initial layer flow, keep that at 100%. Always want retraction on. Make sure that's on. I have my retraction set to 6 millimeters. You can bump this down to 5 millimeters for an Ender 3 or Ender 3 Pro. The 6 millimeters is simply what the Ender 5 uses because it has a longer Bowden tube. And I have a video discussing this in a lot of depth, so I'm not going to go into it here. But 6 millimeters will work fine for all printers, all Ender series printers in CR10. So I just leave it set to that. As I said, if you have an Ender 3, Ender 3 Pro, you are perfectly fine bumping that down to 5 millimeters. Retraction speed is set to 45 before anyone says that the Enders are throttled at 25 for this in the firmware. Yes, I am aware of that, but this isn't going to make a difference on that. If your ender is throttled to 25 millimeters per second, that's going to override this and it will just bump this down to 25. Pretty much every Ender 3, Ender 5 sold in the last year has updated firmware that under the control menu on the LCD, it lets you go in and under motion control, adjust that throttled speed on your extruder. I have mine bumped back up to 50. You go into your LCD menu, go into control, motion, and look for your extruder. It'll be set to 25. You can change it to 50, and then just be sure you go back in under that menu and hit Save Settings. If you do that, it will take advantage of this and use the 45 millimeter per second speed. If not, you don't have to change anything here. Just leave it as is. It will retract at 25 millimeters per second, and that is plenty fine. It works great, so don't sweat this. Minimum retraction travel, that's just the amount the print head has to actually move to trigger retraction. If it's not moving at least this distance, it's not going to do a retraction. Why? Well, this distance is twice the opening of your nozzle. If it's not going to at least open this far, or move this far, you really don't need to do a retraction. These are all stock. We're going to leave those. Print speeds. My current favorite for printing miniatures is 42 millimeter per second for the standard speed. I cut that in half for the outer wall speed, so that's going to bump down to a 21. Inner wall speed is set at 42 still. Top surface skin speed, we discussed this earlier. I'm making that super slow at 15. Top bottom speed is set to 21. Travel speed is at 100. I'm currently testing 120 right now, and that's looking very promising. So if you're watching this video 6 or 8 months from now, and my latest Cura profile has this higher, that's why. Initial layer speed, you always want to print your first layer slow just so it gets better bonding. I bumped that down to 21. Initial layer travel speed is set at 50. If I bump the travel speed up to, say, 120, that'll bump up to a 60. Skirt and brim speed, I print those slow just to get the flow of molten plastic going better. It gives it more time, and you get a better, nice slow extrusion to get that nozzle primed. Let's look at these accelerations. Accelerations I have bumped down to 250 millimeters per second. 250, once you start going over this, you can start having slight layer shifts and see imperfections in the Z axis of the miniature. 250 will do this nice and slow for you. This is simply the maximum acceleration per second for the miniature. Travel acceleration I have set to 1400. This is for when you're not extruding plastic and it's traveling from area to area. I think about the maximum you can really have here is about 1500. So again, 1400s and 250s for all of these. The maximum jerk, which is the maximum velocity change of your print head, we set that down to 5 millimeters per second. So imagine you're in a car doing 5 miles an hour and slamming the brakes on. It's going to be much easier than doing that 42. So what you're doing here is just limiting those velocity changes, and 5 millimeters per second works great for miniatures because you have a lot of fine details. Combing mode. This is essential. A lot of people put this either at all or within infill, and you're still going to get stringing with this. You need not in skin, and that will take care of a lot of stringing issues for people. Avoid printed parts and traveling, turn that on. You set your avoid distance to anything over 0.5 is fine. Mine is 0.625. I think that was just the stock setting, but 0.5 is minimum for the size of the nozzle. That's all stock. All right, cooling. You want your print fan turned on always for a miniature or anything else you print. Fan speed I have set to 100%. You want to make sure fan height is for regular speed is 0.2. That's because our first layer is at 0.2. What this does is that means the fan will not kick on until it is at 0.2 high, which means your first layer will be completely printed. The reason you don't want a fan running on that first layer is you want it to get down and be nice and hot for a longer period for better bonding and better adhesion to that build plate. By setting this to 0.2, which is our first layer height, the fan does not kick on until the second layer of the miniature, and that's what you're doing here. Regular fan speed at 0.2, that just means it's going to be going at 100%. Minimum layer time and minimum layer speed, these are critical. And for anybody screams at me that lift head is turned off, yes, I know it is turned off, and there is a reason for that that I will get into now. Minimum layer time is simply a number that you're going to input so that the print head spends at least this much time, if not longer, on each layer. The reason for that is you want each layer to fully solidify prior to moving on to the next layer. When you print a layer, you're depositing molten plastic on the previous layer. If the previous layer is still soft and it still has a lot of heat retained in it, by adding heat from the subsequent layer to it from the molten plastic and from the radiant heat energy of the nozzle, it's going to be extremely soft. If it's in an overhang area, gravity's going to take over and it's going to deform. So you want each layer to have the best chance of fully solidifying before printing the next layer. On a large layer, that's not a problem. But when you deal with miniatures, that is an issue. That's why things like swords and spears very often get a rippled effect and look horrible. It's because there's too much heat being retained between layers. So this is usually set to 10. I've bumped this down to 7, which is sufficient for a miniature. Minimum speed. This is something I've played with these two a lot, and believe me, these are optimal. The minimum speed is the minimum speed that printhead is allowed to travel at any time. Now, some people set this to 1 or even 0. I'm not a fan of that simply because I like keeping that nozzle moving at all times. If it sits in one position too long, you're going to start deforming and transferring heat to the spot on the layer below the nozzle. So by keeping that nozzle moving at least 2 millimeters per second, you're mitigating that somewhat. Now, these two can come into conflict. And I'm just going to give a hypothetical here. If your minimum speed is 2 millimeters per second, and you have, let's say this guy is holding a spear that has a grand total of 4 millimeters of surface area, at that minimum speed, it's going to complete that layer in 2 seconds. But your minimum layer time is 7 seconds. So what's the nozzle supposed to do for the remaining 5 seconds? Well, normally you would have lift head turned on. It would print that layer of the spear in 2 seconds, lift up for the remaining 5 seconds to allow it to cool, then drop down and print the next layer. The problem is, every time you lift and lower that head, you're getting nozzle ooze and blobs on that surface. It makes a really bad looking miniature. Worse than what you're going to get by just having that layer slightly heated still when you print the next subsequent layer. It's the lesser of two evils. So by keeping this off, what happens is minimum speed overrides minimum layer time. So in my hypothetical situation of a 4 millimeter surface area with a minimum speed set to 2 millimeters, it would print that layer in 2 seconds, and then it would immediately jump up and start printing the next layer. It would just forget the extra 5 seconds you've set here. This combination works really well for miniatures. You can modify it some. If you drop your minimum speed lower and you have weapons or anything that raise above the height of the rest of the miniature, you're going to notice a level change where that height, where the last, for example, if this is holding a spear, once it gets done printing the top of the head and starts only printing the spear, you're going to notice a change in surface width on the spear from the increased heat by going at that slower speed. This will mitigate that. So just, again, I've done a lot of testing, and these are final numbers. I don't see these changing ever again. Build plate adhesion, I use a skirt. I rarely use a brim for anything. In some cases, you may have to. For Fat Dragon products, in the instructions, if there's any deviation to this profile, I will tell you in the instruction sheet, or there'll be a README file. And I'll say, for this particular miniature, use a brim or something. But for most cases, skirts will work well for us. You always want to have at least 200 millimeters. For extrusion length, I'm doing 250. That just gives you a nice amount of priming. PLA does not melt and solidify and remelt and solidify very well. It changes the quality of the plastic. So what you're wanting to do is all of that plastic that was molten from your previous model in your nozzle and your melt chamber, you want to get it out of there for your new print. And that's all this does. Priming the nozzle, doing a skirt or a discharge line along the side of the build plate. That's just getting that older plastic that's been melted twice now out of there before you begin your good model. And 250 will do that nicely. Special modes, print sequence all at once. I don't use experimental features because they're always changing. I am not going to waste my time, running 50 prints to test something only to have it change for the final version. For me to use any of those experimental settings, they're going to have to be approved by Cura and moved into the standard settings before I'll tackle those. So that's it. That is my newest miniature profile. That is version 4-3. Really quickly, the 4 denotes the nozzle size. The 3 is the version. So right now, this is nozzle 4.4 millimeter nozzle version 3. I am actually testing version 4 at this time. When that comes out, maybe a month, maybe 6 months. It just depends how long it takes me to test and what it is I'm tackling with it. So that's it. Thank you for watching. Please click that subscribe button in your bottom right-hand corner.